Okay, in part 2 for Math 118, sections 2.6 and 2.7, absolute value equations and inequalities, I'm going to give you the rules. And we're going to take the 3 problems from part 1 and we're going to apply the rules. There are 3 rules. The first rule is the equality rule, or if you have absolute value equals, and this number here has to be a positive number in order to apply the rules. In part 3, I will explain what to do if that is not a positive number. Okay, if you have absolute value equals a positive number, then the way you solve this problem is you have to break it down into 2 parts. You have to first write whatever the stuff is that was inside the absolute value sign and set it equal to A, write down the word or, and then set it equal to negative A. If your problem is an absolute value problem with a less than sign here, then the way you solve it is you take the stuff that's inside the absolute value sign, or whatever it is, and you sandwich it in between a positive A and a negative A. I call this the sandwich rule. Again, in the original problem, this A right here has to be a positive number. And if your problem is a greater than problem, has a greater than sign in it, you apply rule number 3, which says you take whatever the stuff is, you set it greater than A, you write the word or, and then you take the stuff and set it less than a negative A. I call this the split rule. Again, this number A here is a positive number, and like I said in part 1, the problem has to be set up so that all you see is absolute value on the left side. The first example that I showed you in part 1 was 2 times the absolute value of x plus 5 minus 6 equals 10. And remember, we could not solve it with the 2 here or the 6, so we had to take care of that first, solving it so that we have absolute value of x plus 5 equaled 8. Now this is in the proper form, and we can apply the rule. This is critical that you get this in the proper form or it will not work. That's the first important part. The second very important part is that once it's in the correct form, you apply the rule correctly. The equal to rule says first you take whatever the stuff is that's inside the absolute value and you set it equal to a positive 8. You write the word or, and then you take the same stuff again and you set it equal to the negative 8. You have to do 2 parts or it is a wrong, big time wrong. Okay, so it's like you have 2 little problems here. And each problem you solve separately. Subtracting 5 from both sides, I get x equals 3. The second half of the problem also needs to be solved. So subtract 5 from both sides. X equals a minus 13. Done. Remember from part 1, the second example I showed you was this one. And again, I said you cannot solve this with the plus 2/3 here. So you need to subtract 2/3 from both sides. When we did that in part 1, we got the absolute value of 3x minus 4 is less than 13/3. Okay, so all we see here is the absolute values. And what we see here is a positive number. So we can apply the rule. This is a less than sign. So we are going to use the less than rule. And remember, I call the less than rule the sandwich rule. And the way you solve this then is you take 3x minus 4 and you sandwich it, put it in between minus 13/3 and plus 13/3. In order to solve a sandwich problem, you need to isolate this x in the middle, which means this number here and this number here have to go. I'm going to add 4 first. And when you have this type of a problem, you have to add it to all three sides. So I've got 13/3 plus 4, and it's a fraction, so I need to get common denominators. So that's 13/3 plus 12/3. So if it's easier, instead of writing a plus 4 here, write 13/3. And, oh, excuse me. Darn it. I hate that one. I hate that. Okay. Write 12/3. 4 is 12/3. And same with over here, write this as 12/3. Okay. So minus 13/3 plus 12/3 is a minus 1/3, less than 3x, less than, and 13/3 and 12/3 is 25/3. Still not done because the x has to be alone, so now I need to get rid of the 3 by dividing 3, and you have to divide all three sides by 3. That gives me x in the middle. And what is 25/3 divided by 3? Well, that's the same thing as 25/3 times 1/3. So on the right side, we get 25 over 9, and minus 1/3 divided by 3 is the same thing as minus 1/3 times 1/3. So on the left side, we get minus 1 over 9. Because this represents infinitely many solutions, we want to represent the graph, the solution, on a number line. 25/9 is positive, somewhere over here, and negative 1/9 is somewhere here. And using interval notation, you use open parentheses because it's not equal to, and you draw a line in between the two. Another way of graphing this would be to draw open circles and then connect the two. The solution in interval notation is parentheses minus 1/9, comma, 25 over 9 parentheses. Okay, so for the third example, I'm not actually going to use the problem that I did in part 1 because it ended up with a negative number right here, which is one of the special cases that I'm going to explain in part 3. So I'm going to take this other example, which is absolute value of x plus 5 is greater than 25. This is, absolute value is already isolated for us. This is a greater than rule, and this is a positive number. Okay, that's rule number 3. Rule number 3 says you take whatever the stuff is that's inside the absolute value signs. You set it greater than 25. You write the word or. You take the same stuff again. Oops, and it wasn't a 2, it was a 5. Love those little mistakes. And then you set it less than a negative 25. Remember, on my rules, I called this the split. It's still a two-part problem, and you have to solve each part. If you only do half this problem, I start to get very angry after a while, because it's wrong. So, the left side you subtract 5, you get x is greater than 20. And for the right side, second half of the problem, also solving for x, I get x is less than minus 30. Okay, infinitely many solutions. Draw a number line. Hopefully I will get better at this. I'm going to try one more time. Okay, here's 0, and here's 20, and here's minus 30. So, x is greater than 20, looks like this. X is less than minus 30, looks like this. And when you look at the graph, notice that the two solution sets are going off into opposite directions, which is why I call this a split. Now this solution written in interval notation looks like this. You read a graph from left to right. So if we start out here, we're out at negative infinity. We go all the way up to negative 30. We use parentheses because it's not equal to negative 30. If it was equal to, we would use a bracket. Then we write this symbol, which stands for the word or, because then nothing, and then we write parentheses 20, because then the solution begins again at not at 20, but very close to 20, and continues on to infinity, parentheses. That's the end of part 2.